limit as x approaches 0 of sine of nx over x, right? That was right. Yep. Okay. So they want us to, there we go. So I'm going to start with n is 1. Okay, so basically sine of x over x. So sine of x 71. And graph it just to see what happens with it. Okay, so as it's doing that, it basically says to me I want to see the graph better. So I'm gonna, it doesn't seem to go very high, so I'm just gonna change the window to make my y min -2 and my y max 2. Let's see if that does anything to help us. Okay, and they're asking us for, in this case, the limit as x approaches 0. So remember that this is 1, this is 2 here. Jesse, you okay with this?
Yeah, it's just not showing up in my calculator when I press the graph. I'm in degrees.
That's a problem.
Yeah.
Okay, so now, what's the limit as x approaches 0 of the sine of x over x? 1? Like you can see coming from here it's going towards 1, coming from here it's going towards 1. Yep.
What are you looking for n in the graph?
Well, we're going to do different ends. That's what it basically asks. It says, use the graphing utility to evaluate this for several values of n. So right now, I made n 1. Okay. So when n was 1, what was our limit? 1. Okay. So what should we try now?
N of 2.
N is 2. So, whoops. Second insert, we'll put a 2 there. So now we're doing the limit as x approaches 0 of the sine of 2x over x. What does it look like? Looks like 2, doesn't it?
Yeah.
You know, from both sides, it's going to 2 from here, it's going to 2 from here. Might have to change the window if we're going further. -4 to 4. And then I'll change this to 3x. So when n was 1, it went to 1. When n was 2, the limit was 2. Huh. What are we kind of hoping this will be?
3.
Hoping it'll be 3 because, God bless you.
Thank you.
So let's see. How do you feel about that? You like?
Yes.
Yeah.
Me too. So what does it appear to be? What's the limit as x approaches 0 of the sine of nx over x? N. Yeah.
You do something,
Try my best. We okay here? See what the title of this section of questions is, by the way?
Multiple choice. Oh.
AP exam prep questions. Those are ones that you should definitely try. What is the limit of f of x as x approaches 0, where f of x equals e to the 3x minus e to the x over x? So, e to the 3x minus e to the x. Okay, that was all that size, over x. Okay, so, and they want the limit as x approaches 0, right? Yep. Okay, that's what it should look like. If we plugged in 0, would that be good news or bad news here? Why? 0 in the denominator. So immediately we go, okay, we can't just plug it in. So a couple of different ways you could do it, but for right now, we have two options. Number one is do a chart and start plugging in numbers around 0. You guys remember, I am lazy. I don't feel like plugging in all those numbers if I don't have to. God bless you. So I'm going to graph it. Let's see what it looks like. Y equals parentheses, second e to the 3x minus second e to the x, right, over x. You okay with that? And let's see, I mean, I may have to change the window. I to be honest, I have no idea what this is going to look like. Okay. So I'm going to do two things. First thing I'm going to do is kind of zoom in on that. So I'm going to change my window. I'm going to make my x min -1. I'm going to make my x max 1. And I'll make the y min my y min -2 and my y max 4, just from what I saw. I know what I'm guessing here. Did you do the same window I did? So yeah, kind of put everything in parentheses. Well, remember, we're talking about a limit. So basically, when we're saying a limit, we're saying as it's getting closer to 0, where is the graph approaching? So if there's a gap in the graph, we actually don't even care about that. We just want to know from this graph, where is it going as x approaches 0? And it looks like it's going to 2. Does that make sense? And so hoping that that's the answer, and it is. Yes. Yep.
Is it always going to be on the y-axis?
Well, x, that's where x equals 0. So as x approaches 0, excuse me, as x approaches 0, we're talking about as it approaches the y-axis. So if it was as x approaches 2, then we'd be out here somewhere or something like that.
What do we plug into a window?
What I did here is because I just cared about when it approached 0. So I didn't care very much about far left or far right. I just went from -1 to 1 on the x's. And then on the y's, it looked to me like it was, very briefly, it looked like it was above 0, but not way above 0. So I just went up to 4. Does that make sense? And so what you start to see is that I like finding limits when they give us the graphs. You know what I mean? It's kind of right there. Okay? I'd like to do this problem real fast. Oops, I just messed it up. The limit as x approaches 0 of the sine of 1 over x. Okay? And by the way, Thank you. By the way, on this problem and the one before, the other option, I don't remember, I think I said there are a couple of options. The other option besides this is to go to the table over here. And when we go to the table, and remember, on my delta table, this is from Friday, I guess, I put 0.0. I put it, the delta as 0.01. And so you can really see pretty well that it's getting close to 2 and then it's just over 2 and stuff like that. So that's the other option. If the graph isn't exactly what you want, go to the table and find those values. And the nice thing is that when you start to do, you know, the annoying ones where you had to do the whole chart of, you know, 0.01, 0.001, 0.0001 and stuff like that, as you move on, you'll be able to use the table to get a lot of those values that you need. Does that make sense? All right, limit as x approaches 0, sine of 1 over x. Oops. All right, and I'm going to do zoom trig because it's a strict sine graph here. So I'm going to go zoom 7 and we'll see what happens here. Whoa. That's weird. So it makes it a little less obvious. So let's zoom in on it and see what happens a little bit. So window, let's make our x min, I don't know, go try negative 1 to 1. It didn't seem too high. Maybe let's go just negative 2 to 2 on the y's. See if that helps. It's kind of wild how it's nice and calm here, and then all of a sudden it comes in and it comes out here and starts to go nice and calm again. Huh. If you had to guess, is there a guess out there?
Undefined.
Let's go to the table. Is that okay?
Are you in Zoom training?
Is that table good news or bad news?
Oh, there you go.
Good.
Good.
Is it 0? It's so random. Numbers should just. No, it's just.
As it gets close to 0, is it getting close to one specific value? No. One of the sides is positive a half, the other side is negative a half.
So it's non-existent?
It's not like 0 is right in between them, but it's not approaching 0. It's kind of almost getting further and further away. Like at negative 0.02 is 0.26, and then as it gets closer to 0, it goes up to 0.5. And then negative 0.5, and then so it's kind of a mess. This is what we call oscillating behavior. Oscillating behavior. When a graph has oscillating behavior, in other words, it's doing that, okay, it has no limit. There is no limit there. Did you say it was stupid? Going down, it's closer. And then, yeah, so it's not going the same number. It's actually going further away. So this is called oscillating behavior. If a graph has oscillating behavior, it has no limit. Okay? So that's the one situation we didn't talk about. That's the one situation we didn't talk about on Friday. Okay? Before I forget, okay, before I forget, here's our new ACLab board. If you want to sign up for ACLab, this will always be up here. You cannot sign up the day of anymore because they shut down the list, the Google Doc, at 7:30 a.m. So you'll see, you guys are obviously second hour. I need your name and I need your third hour teacher because I can't do that for everybody. And if you were to sign up today, then I'll get you on for tomorrow. If you want Thursday, then make sure you're signed up before the end of school on Wednesday or super early on Thursday for me to get in, okay? On Tuesdays, I have priority. So if you want to come on Tuesday, then you're in. On Thursday, you can sign up here, but if somebody else calls you, like, I know it's English priority day. History might also be that day, I'm not sure. But they would have, some of them would have priority. But on Tuesday, math has the ultimate priority. So, okay there? But it's there. The only difference from last year is that you got to list your third hour teacher because I got to put that on the doc. Okay? Questions? Guys in the back, just another couple minutes or so, okay? All right, so section 2 dealt with limits, doing the charts like numerically and graphically. Okay. Section 3 is where we really start to get into it a little bit more. We're going to do the analytically part, okay? Which means more algebra and things like that. So we're going to give you some basic limits, and these are ones that you're just going to have to know. All right. Let's see if I can zoom a little bit. That helps a little bit at least. Okay. Let B and C be real numbers and let n be a positive integer. So the first one, limit as x approaches c of b equals b. In other words, limit as x approaches 5 of 2. Okay. Well, in a way, that's basically saying y equals 2, right? So when x is approaching 5, what's this graph approaching?
2.
2, because what is this graph?
2.
What's the graph? I know, what does it look like?
A straight line.
Horizontal.
It's a horizontal line, right? It's a horizontal line at 2. So as x approaches 5, where's that horizontal line going?
2.
Yeah, 2. It's not going. It doesn't matter whether x is 5, or x is -7, or x is 1/4, or anything like that, right? If you have a horizontal line, the limit is just going to be the value of that horizontal line. Does that make sense? So the limit as x approaches 5 of 2 is 2. Does that make sense?
Yes.
Okay. Next one. Limit as x approaches 3 of x. Okay. Now we're saying y equals x. What does y equals x look like?
It's a diagonal line crossing the origin.
Diagonal line through the origin, slope of 1. Okay, y equals x. as x approaches 3, what's x? 3. Right? Does that make sense? This is basically just saying, what's x? Well, x is approaching 3, so x is 3. So that's the second one. The third one says the limit as x approaches 4 of x to the 4th. Nope, hang on. Of x to the 3rd. There we go. What would your logic say to that? It's the limit as x approaches 4 of x to the 3rd.
It's 4 to the 3rd.
4 to the 3rd. That's, yeah. So these basic limits to me are very logical. They're also plug-inable. I'm sure there's a better word for that, but we can work with plug-inable at this point. Is that okay?
Yeah.
Oh, and he did some of them down here, the basic ones. So questions there? All right. Now let's get to the properties, and this is the stuff that we want to spend a few more minutes on. B and C be real numbers, n be a positive integer. Let f and g be functions with limits. Limit as x approaches c of f of x equals L. And limit as x approaches c of g of x equals k. Scalar, multiple. Okay. So if we have something that says the limit as x approaches 3, let's do this first, of f of x equals, I'm making up numbers here. Okay? So we have some function such that the limit as x approaches 3 of that function is 5. If we multiply that function by 4, then we would also multiply the limit by 4. That's what that's saying. You're going to want to refer back to these at some points because you're not going to remember all of these off the bat, I'm sure. But they also all will kind of make sense. So, or at least they're all fairly logical. Questions on that one? This is a scalar. If we multiply it by a function, then the limit gets multiplied by the same number.
Well, what's the answer?
This would be the answer over here. So I don't know what the function is. I just made up the function.
Oh.
I just called the function f of x. Okay, guys, we should be about done back there. Okay. In the basket when you're done. Yeah. The second one says that if we have two functions that we're adding or subtracting, we want to find the limit of the sum or the difference of those two functions, then we would just add or subtract the limits in the first place. So if we said limit as x approaches 3 of f of x equals 2, and the limit as x approaches 3 of g of x equals -5, then the limit as x approaches 3 of f of x plus g of x equals the limit of f of x is 2, the limit of g of x is -5, so the limit of the sum of them is the sum of them, which is just -3. And this is holding true for all of them, okay? If we multiply a scalar times the function, we multiply the scalar times the limit. If we add or subtract the functions, we add or subtract the limits. If we multiply the functions, we multiply the limits. If we divide the functions, we divide the limits. If we do a power of the function, we do a power of the limit. All of that stuff is exactly as logical as you would expect it to be, and you'll see that in some of the problems we're gonna do.
So does the limit have, or does the limit as x approaches 3, if we want to add 2 of them, it has to be the same?
It has to be the same number there, that's what
Yeah.
you're saying? Yeah, yep. And we would write it like this, so we would have to know, yeah, we'd have to know those. Okay, so, for instance, let's come over here. How we're going to use that is what we're talking about here. Okay, so we want to find the limit as x approaches 2 of 4x squared plus 3. So what they're going to say is, what's the limit as x approaches 2 of 4x squared? So what are you going to do here? Just plug in 2, right? This isn't one that we're going to have issues. There are no radicals, there are no denominators. This is just going to be a nice plug-in thing. So if we plug in 2, what do we get? 16. 2 squared is 4. 4 times 4 is 16. And then what's the limit as x approaches 2 of 3? 3. So the limit as x approaches 2 of this plus this should be the 16 plus the 3 gives us the 19. That's how they're doing it. Now, you also could have just plugged the 2 in to the 4x squared plus 3. And you're going to get the same result for the same reasons. Okay. I'll give you a theorem and then we're going to talk about it. Okay, what this is saying is, the first part is basically saying, plug in the number. Okay, like we did right here. This direct substitution property is valid for all polynomial and rational functions with non-zero denominators. So basically what they're saying is what we had said the other day, which is, if we can plug in the number, just plug in the number. Okay? And that will work all the time unless, as we've seen, we end up with 0 in the denominator. And so what becomes the obvious question? What do we do if there's a 0 in the denominator? Okay? And so there are a couple of different options. Right now we'll start with this one. So the limit as x approaches 1 of x squared. Oh, that's not the one I want. Let's do this. X squared minus x minus 2 over x plus 1. Let's do that. That's not helpful. -1. That's the limit as x approaches -1. I thought it was giving me one problem. So, how does the plug-in thing work here?
Plug-in
Well or
doesn't-
not so well?
Not so well.
Not so well, because we would get
0 now.
0 in the denominator. I believe we'd also get 0 in the numerator. And so, what are our options at this point? At this moment, as you know it? Option 1, graph it. Option 2, table it. Look at the table, see where it's going. Here's option 3, and this is one that we're going to use more and more as we go along. Okay. Simplify that. Factor. Yay. So let's factor. X minus 2, x plus 1 over x plus 1. Is that right? Yeah. Then what?
Cancel.
Cancel, which leaves us with
X minus 2.
X minus 2. What could we do now? Now we could plug it in. Which would give us, that would be our limit. Let me show you. Y equals parentheses. X squared minus x minus 2 divided by parentheses x plus 1. So you see what the graph looks like. So if we're looking for the limit as x approaches -1, I'm going to get closer to that. So I'm going to go x min of -2, x max of 0. And I'm going to go -5 to 1. You see what's interesting? There's actually this little dinky gap right here. Hard to really see it, but if we look, and there's our point, -1, -3. And if you look at it on the table, I gotta get to -1, huh? So, that's not what I want. I still want that. And you see it there. See how it's approaching -3 there. So we just dealt with this limit 3 different ways. Numerically, you can see it. Graphically, you can now see it. And then we also did it algebraically. Okay? All of those things, they're all different options with how to get limits. Other questions on that? Does that make sense? If we end up with 0 in the denominator, and in this case, most of the time it's going to end up being 0 over 0, we can factor cancel and then plug in. Okay? All right. Where are we? Yep. I don't know. Should we be done?
Yes.
Okay,
No.
we can be done.
We should start homework.